Hello everyone, in this recording we will be doing an example where we are using a quadratic term and doing some transformation using logarithmic transformation. Let's look at the example. Again, we have an example about happiness, which is good. Research often rely on surveys to capture a subjective assessment of well-being. One study finds the holding everything else constant. People seem to be least happy when they are in their 40s. Wow, interesting. Another study suggests that money does buy happiness. Do you agree with this or no? But its effect diminishes as income rise after or above $75,000 a year. Interesting. So the file includes 100 working adults' self-assessed happiness on a scale of 0 to 100, along with their age and annual income. First, I'm going to clean this and this. Then I'm going to run. Again, I'm calling this my data. It's in chapter 8. We have two arguments. We need the library, two libraries here. One library, which is readxl. By the way, before we continue, you must have watched the lectures, and you must have watched the, what do you call it, the cross-validation techniques lecture. So let's run this. We have 100 observations. We have 3 variables. Let's look at them. Happiness, age, income. Very simple. Just 2 variables. Let's explore these. Because we're doing regression, we're assuming that all of the variables are numeric, right? And they are all numeric. So estimate and interpret linear regression model, the happiness based on age and income, and the regression model for happiness based on age squared, and ln income, log of the income. So let's build first the linear model. Linear model, happiness, my data, summary model. Happiness doesn't exist. Spelled incorrectly. Did I run this? Happiness. Linear model, happiness. Sorry, comma, my data. Okay, so this is just a quick look. We have a relatively low adjusted I can't say low or high, but this is not, because our adjusted R squared, or the R squared, just less than 50%. That means 50% of the response variable is explained by this model. 50% of the variation of the response variable is explained by this model. So we have another 50% is not explained. So that's why I said, oh, it's low or something. Anyway, but all the variables are significant. Excuse me. Anyway, let's build the other one. Quadratic. Let's call it quad model. Quad. Happiness, tilde, dot, not dot, because we need to add more terms. Income plus age. When you add age squared, when you add the age squared, we're gonna use a function called I. This is the way that when you add a term, a squared term. So on a squared term, you add I, parentheses, the variable, square it, close the parentheses, plus semi-log. That means we have to add log income. So we did a transformation here. So we are adding 2 terms. One is the age squared, and we are adding the log income, which is transforming the income. And maybe the question arises here, why do we do this? We do this for many reasons, as we said before, that maybe we would like to capture the non-linear relationship between the income and the happiness. In some cases, the effect of the income on happiness might not be constant across all of the income levels. When you take the logarithm, this can help addressing this issue. Maybe by taking the logarithm of the income, we are trying to diminish the effect of the marginal utility, and we're not talking about this. Or maybe the variance is not constant, so by transforming, we are trying to make the variance of the residuals across the cases to be roughly constant. So anyway, there are many reasons of doing this. We will not be focusing on these things, but it's a good idea to know. So let's run this, by the way. Okay, we are building. By a quick look, you can see that the adjusted R squared becomes much higher than before. So, and okay, someone's gonna say the income is not significant, but it's not a big deal, okay? The overall, the collective impact of the variables are significant. The individuals we have, the income is not significant, but at the same time, the predictive power is high compared to the previous one. Anyway, we'll not be talking about these things now. Does the question say which one is better? Estimate. Yeah, I mean, let's because the next part says predict happiness, Okay, let's do this. Let's just compare them quickly as we did. So the second model appears to be better. It shows a higher adjusted R squared, which is 68%.77 compared to the first model, which was about 48 something percent. So including these variables, which is the age squared and the length of income, contributes to a better fit of the model to the data. And this suggests that it provides more accurate representation of the relationship between the predictor variables and the happiness variable. And as I said, the F value here is higher than that one. So, and both of them are significant, but the F value is higher. So this tells us that the second model is much better. So if I do the comparison, let me write this down. Okay, we wrote this down and we have this. Now we are going to predict the happiness with income equal to $80,000 and age equal 30, 40, 60 years. And we're going to repeat this for different values. Let's do this for both, or using both models. So I'm going to use predict. We are going to plug in values. Okay, did I, let me show, okay, let me say something by the way. Let me write the estimated model is happiness hat. Let me type this, let me pause. So this is the second model. We have negative 0.2 plus 0.000 times income minus 2.4 times age, etc. Age squared, log income. So these are the estimates, the values of the b's, okay? So this is my estimated model. And if you look at the coefficient of the income is really small, but the income is in thousands, I guess. Let me look at my data. Yes, we have big numbers. Anyway, so this is the estimated model. And you can do the same thing with the first one without having the last two terms, okay? So to predict this one, I'm going to plug in data frame. I'm going to plug in these values. C, not C. Age is what? Age is, okay, age is, we have three values, so that's why I'm going to add a vector C. 30, 45, 60. Different ages with one income. So the income is 80,000. By the way, don't put the comma and dollar sign here. It's a number. It should be a numeric number. Okay. So if you got error and if you're stuck in an error from the previous ones, that means you're trying to put the comma here. No, this is a numeric. So this is to predict using the linear model, and let's copy this and do the prediction using the quadratic model, quad model. Okay. Let's run these and look at them. The first one shows the linear model, the second one shows the quad model. As we said, we're going to use the second one, not the first one. So there is no point of do the prediction using the first model because we are not adopting the first one. Just for the curiosity, actually, I'm doing this. So look at the second one because we said it's more accurate. It's better fit. It fits better. So look at the first values. It's a big difference, by the way. Big difference for the age of 30. Age of 30 has an income of 80,000. Look at the two different models. The second one gives higher score of the happiness compared to the first one. In the first one, he looks miserable here, the person. But the second one is much better. For the age of 45, there is no big difference. For the age of 60, there's a slight difference, by the way. So there is no need to do this, okay? Because we are adopting the second model. Now we're going to do the opposite way around. We're going to do the prediction, but with different income, with the same age group, with the same person, like 60 years old. So the age is 60 here, but the income is C. We have different incomes, 75,000, comma, 125. And we have problem with the dollars here because dollars, I'm going to take them off. Or you can add backslash dollar, put them between dollar signs, just backslash dollar will do the job. Okay, so quad model, we have, when you do predict function, as we said many times, We are plugging these values into this model. We are plugging the data frame values into the quad model. It's just a plugin. It's like what you're doing in math. Okay. Oh, we have a problem here. What is the problem? That quad model predict data frame, age, income. Maybe one more. Look at the parentheses. They are highlighted. So this one is the closing parentheses of this one. So we have one missing. Okay, a 60 years old person, if his wage or salary or income 25,000, his happiness is low, but the happiness is increasing as the money flows in, right? So the claim is not accurate because the money, money makes more money, higher happiness.